3, questions 21 to 35. In this part, you will hear 3 talks, lectures, or conversations. The talks, lectures, or conversations will not be repeated. There are 5 questions for each talk, lecture, or conversation. For each question, choose the right answer, A, B, C, or D. Now, we are ready to start. Listen carefully.
Questions 21 to 25 refer to the following conversation.
Today, we're going to discuss earthquakes and what causes them. Earthquakes occur when stress builds up in the Earth's crust and is suddenly released along faults, which are fractures in the rocks. The energy release travels as seismic waves, causing the ground to shake. Most earthquakes happen along plate boundaries where tectonic plates interact. There are 3 main types of boundaries: convergent, divergent, and transform. At convergent boundaries, plates move toward each other, often resulting in powerful quakes. The 2004 Indian Ocean earthquake was an example of a megathrust quake caused by subduction, where one plate moves beneath another. One of the most commonly used tools for measuring earthquakes is the seismograph. It detects ground motion and records it on a seismogram. The magnitude of an earthquake, which indicates the energy released, is typically measured using the Richter scale or the more modern moment magnitude scale. Earthquakes can lead to significant destruction, especially in urban areas. Besides structural damage, secondary hazards like fires, tsunamis, and landslides may follow. Engineers and scientists are working together to design buildings that can withstand seismic activity and to develop early warning systems to reduce casualties.
Questions 26 to 30 refer to the following conversation.
In today's lecture, we'll explore inflation, a key economic issue where the cost of goods rises faster than people's earnings. This means individuals need to work longer just to afford the same items they used to buy more easily. To illustrate, suppose a loaf of bread costs $1 this year and the average wage is $10 per hour. That implies a person has to work for 6 minutes, or 1/10 of an hour, to earn enough for one loaf. But mid-year, the price increases to $1.25 while wages remain unchanged. Now, that same person must work 7.5 minutes to afford it. By the end of the year, if wages go up to $11 per hour, but bread costs $1.50, they'll need to work over 8 minutes to buy it. So even if salaries increase, real purchasing power might decline, meaning people can afford fewer goods and services than before. Economists identify different degrees of inflation. Moderate inflation doesn't distort prices drastically. Galloping inflation, however, involves a dramatic price surge, often more than 100% within a single year. Then there's hyperinflation, an extreme scenario where currency loses value so rapidly that people rush to spend their money before it becomes worthless. Hyperinflation typically brings severe political and social instability.
Questions 31 to 35 refer to the following conversation.
Producing enough energy to meet our needs has become a serious problem due to the rapidly rising demand, driven by the world's growing population and expanding industry. Burning fossil fuels like gas, coal, and oil harms the environment and is unsustainable. Scientists have been working on deriving energy from renewable sources, such as the sun and wind, without causing pollution. Today, I'll focus on marine renewable energy, which harnesses ocean movement. Marine renewable energy has 3 main categories: wave energy, tidal energy, and ocean thermal energy conversion. Wave energy involves devices like Wave Dragon and Mighty Whale that harvest energy from the constant motion of the ocean. Although wave energy has great potential, it is erratic, with waves moving in all directions. The irregularity complicates the development of efficient technology. Additionally, ocean sediment might be disrupted, causing environmental issues. Tidal energy, on the other hand, is predictable, as high and low tides follow a fixed schedule. Effective tidal energy requires a difference of at least 5 meters between high and low tides, which naturally occurs in only about 40 locations globally. A proposed project in Wales involves creating a tidal lagoon, where water flows through turbines to generate electricity. The system would produce power 4 times a day for around 14 hours. It's a reliable, low-maintenance source of energy that doesn't depend on weather conditions and doesn't require fuel. The project is expected to create over 2,000 jobs but may harm local ecosystems by disturbing migration patterns and increasing silt buildup. The final category is ocean thermal energy conversion, which works by utilizing temperature differences between surface and deep water, primarily in tropical coastal areas. Marine renewable energy offers promise but also presents challenges that must be addressed for sustainable development.